Alright, this section right here is, we've talked about scale factor the whole entire chapter, but this one's called scale drawings and models. Now, this at this point we may be a little bit outdated on this lesson right here, but there's still, I think there's still reasons to learn this stuff. So, I mean, the reason I say it's outdated is because with the advent of GPS and all that kind of stuff, I mean, they pretty much tell you how far you have to go, and with Google Maps and everything else, it's just amazing. The technology today with map making and all that kind of stuff. Well, back in the day, wasn't that long ago, yeah, you took a look at a map and you had to figure out like how many miles it is to get from point A to point B, and you would I actually did this. Okay, if I was going to go on a trip and I hadn't been there before, I would actually take a map and kind of take my ruler and measure it out the roads and see what the scale factor was and all that kind of stuff to get a general idea of how many miles it was to get to my destination. It wasn't very accurate, but it gave you a general idea of how many miles it was, and if I knew how many miles it was, it gave me a general idea of how long it should take me to get to that certain place, because you figure if you average, maybe like 50 to 60 miles per hour on a trip, and then you know how many miles it is to get to that certain place, you can figure it out. But now you don't have to do that stuff anymore. What do? You just punch in your destination, and it tells you the time you should arrive, and if you don't hit any major traffic or nothing crazy happens, or you don't go super slow or super fast, you pretty much arrive right when it tells you you're going to arrive, within just a few minutes. It's just absolutely amazing how they can do that. And of course, when you're on the road, it gives you updates if you hit traffic and stuff like that. And these GPSs nowadays, they can figure out if you have some traffic. They know, they've got the traffic information on the GPS, and they know how long you're going to be in traffic and everything else. It's just absolutely amazing. But in the old days, it's not that old, okay, it's probably not that many years ago, we used to use maps and that kind of thing. And now I always liked maps. I always enjoyed maps and I always thought they were kind of cool. So what we're going to do is talk about this thing. Now this doesn't always just have to deal with maps. We'll talk about something else as well. But we call these scale models or scale drawings. Let's just call it a scale drawing for right now. Okay. So for instance, if you're going to go somewhere and you wanted to look at a map in order to go there, you don't have to have a map that is full scale. That would be pretty tough, wouldn't it? To fold up a map that's full scale. You know what I mean by full scale? For every mile you go, the map is a mile long. That would be kind of ridiculous, wouldn't it? So yeah, that would not be a good idea. So what we do is we take our map and we make it a lot smaller, but then we say, okay, for every inch on this map is so many whatever, yards, miles on the map. Okay, that kind of thing. And that's what we're talking about. We're talking about a scale drawing. So let's see if this picture's probably might be humongous. Yep, that's what I figured. Let's scale it down. Okay, use that word scale. So let's do that. And so I hit the shift key. Why do I hit the shift key when I do this? So it stays in what? Proportion. Very good. Okay, so it stays in proportion. And there we go. So Georgia, there we go. Yeah, you can't see it too well, but I'll zoom up a little bit. So here's a map of Georgia, and here's Atlanta, Georgia, right there. I never really had any idea where Atlanta was as far as in reference to Georgia itself. I always thought it was a little bit closer to the ocean, but it's not. It's pretty far inland, isn't it? See, the Atlantic Ocean's right here, and the eastern seaboard is right here, and Atlanta's about right there. So if you zoom up a little bit, and let's just look down here. Can you see it? Look at this thing. What's that say? Oh, it's some name. Albers equal. Put it in their blocks right here. Albers equal area projection. I don't think that's our scale factor thing. I don't know. It might be. Maybe it is. But what is this? Like if I measured it out, let's just pretend. We'll just make this up. Okay, let's say that this is an inch. Okay, so every inch you go on your map, how many miles is that? It's 20 inches. Okay, so if I wanted to go from Atlanta to Albany, my wife's uncle lives in Albany, Georgia. Never been there, but say we were going to go there, and you wanted to go down 75, and then you get off this little crooked road and go right here. What would you have to do? You take your little ruler, right? Now this is not exactly straight, but you could take your ruler and figure out how many inches is to Macon, Georgia, right? And then down here to this road where you're going to get off, and then measure this. It's kind of squiggly like this, but you kind of use an idea, figure out how many inches is it, and then you can figure out how many miles that you had to travel to get from Atlanta to Albany. Does that make sense? All right, yeah, you've seen that kind of stuff before. So that's what we're talking about when we talk about scale drawings. Pretty simple stuff. So let's use the example. I just wanted a nice picture for us. So let's just do the I'll tell you what, let's just do this. All right, we'll use our own numbers. So where do we want to go? Do we want to go to Albany, or do you want to go to Macon, Georgia, or do you want to go to Augusta or Savannah? Let's go to Savannah. Let's go to Savannah. Actually, you know what we could do? Let's do this. Well, yeah, you got to follow your route, because
you can't just go like.
Nah, you can't just go a straight line, because you don't always travel in a straight line, right? Does this go to the front? Yes, it does. Yeah, you'd have to go the route that you're going, right?
Yeah, but like for the first one, it says Diamond to Oklahoma City, and that's Diamond to Oklahoma City. So how would you get there?
Was it the first? Oh, it's the actual first problem.
How would you get there?
It says, well, you got to read the question. It says find the actual distance between each pair of cities.
So would you just
But if you were actually driving it, listen, I'm explaining. If you were driving, you wouldn't actually put a straight line from point A to point B, because you're not going to drive along that route. Okay, you measure, you know, how far you're going to drive. Okay, let's just go to Augusta. Is that all right? Sorry, Savannah. Now we can go to Savannah. Watch this. We do this. Does this thing rotate? And this is not to scale or anything. I'm just trying to... Oops, what just happened there? Let's try this again. Let's grab this. Oh, okay, there we go. Alright, this is not exactly to scale, and I'm sure this doesn't correspond to anything close to the actual mileage that it is to this place. But what would we do? Now, if I could rotate this thing. Can I rotate this? Yeah. Okay, so we're going to go from where? Atlanta to... Yeah, but we're not going to go straight to Savannah. Let's say we want to go to Augusta, and then we want to go... Then we want to go to Savannah. So that's fairly straight shot, right? If you look at that road right here, looks like Interstate 20. Right, that's fairly straight. So how many inches is that? About from the center. We'll say 8. We'll round it. This is all big time rounding here. Okay, so we'll say it's about 8 inches. And how many inches or how many miles was it to 1 inch on this scale?
20.
It was 20, I think it was, and we'll just make that up. Okay, we'll just say it was. So now let's go from. So how many miles is that then? It's 8 inches, so how many?
8 times 20.
Right, which is 160. Right. So now again, I'm sure it's not even close to 160 miles to from Atlanta to Augusta. We could probably look at it and see what it is, but let's just do this. There we go. Tilt it this way. Let's just try to tilt it a little bit more so we get a nice shot to Savannah. And we've got it. They spelled the right way? Good. Alright, that's not too bad. So how many inches from Augusta to Savannah? About 5. So how many miles would that be? About what? About 100, right. It's about 100. So about, you add up the two distances, and it's 260 miles. And so that's what you would have to do. That's a little bit long way to do that, but that's what you would have to do to get from Atlanta to Savannah. Okay? All right. So let's write some stuff down without all this nonsense up here. Let's go to this. Let's go to this. Oh, there we go. I was wondering where my stuff was. There it is. All right. So what would we say? Let's say 1 inch. We just guessed this. These are just numbers that we made up. Okay, so 1 inch is what? About 20 miles, correct? Okay, so that's your scale right there, because they'll say scale. That's what it is. And so if you measured 8 inches on your map, if you actually measured 8 inches, you want to figure out how many miles is that, correct? So what would you do? So this is what I would do. I would go watch. I'd put my scale factor, my scale down. I'd put 1 inch equals 20 miles, correct? And then I've got to figure out, if I've got 8 inches, what am I going to do for down here? I'm going to go 1 inch is 20 miles, so 8 inches is what? X miles. Would you agree? Now, again, these numbers that we're doing are pretty simple. You could just do them in your head, but you know they could get a lot more complicated than that. Would you agree? So we want a little system to be able to do this. So what do? We cross multiply, don't we? So it's 1 times x is x. Now watch my units. I just want to show you what happens to the units here. So if I multiplied inches times miles, it's what? It's inches miles, right? Inches times miles. Would you agree if I multiply those together? All right, and then that's going to equal this times this. And what is that? Actually, does that work out? Forget the units. Forget the units. I don't know if I can explain that. You can. I would just multiply it, okay? Especially because this is 1 times x. There's nothing that's going to reduce actually on this one. Nothing will reduce here because 1 times x is x, and then 20 times 8 is what? 160. And that's what? It's how many what? Miles. Because we already found out how many inches, and this is going to tell me how many miles it is. So it's 160 miles. Again, we did that in our head already, but that's the little formula that you're going to use here to do that. All right? So that's talking about maps. Well, my dad flies these, he doesn't fly, well, I shouldn't say real, he gets a little offended if I say real airplanes. He says, he flies these remote control airplanes, right? And he goes to Lum's Pond, and they got this place, and he's really into it. He's got tons, half the basement is filled up with all these planes and stuff, and real big remote control planes. They're not like little electric planes, they're gas powered, and it's a big deal. There's a lot of people that are involved in that. It's a nice retirement kind of, but there's young people that do that as well. There's kids out there that do it, and they fly the airplanes, and they fly around and land and crash every once in a while. They don't try to crash, but they do sometimes, and all that kind of stuff. But those are called scale models. They're not full size. Now, when I one time referred to as, to a plane like a passenger plane as a real plane. I said, "Oh, that's a real plane." He says, "Oh, that's a full scale plane." So you got full scale, and then you've got the smaller ones, right, which is not full scale. And so how do you know what the scale of this is? For instance, on page 513, if you look at it, they give you this scale, and we call this a scale model. We call that other one a scale drawing. This is a scale model. All right, so let's say they use this with cars, right? People, they make model cars or trains, model trains. Anybody know anybody that's really involved with model trains? I mean, some people are just...
My whole basement.
Yeah, right. Some people are just crazy about model trains. I have an uncle who made a whole entire room in his house, an extra room just for his trains, But it's pretty cool. I mean, I think half the fun...
It's not cool. It's not cool.
I'm speaking. I think half the fun for people that are into that kind of stuff is not just sitting there and watching the trains go around. I mean, that's kind of like a nice thing to do. But I think half the fun is just designing it, putting it all together, the process of building it, I think is probably more fun to them than actual just sitting there, turning it on, and letting the trains go running around. I mean, it's like, how long can you sit there and watch trains go, round and around? I mean, you can do it for a while, but... I think the fun is in making your little town. That's what they usually do. They try to simulate like a little town with the train coming through, and you get your little people on there. You ever see that stuff? Yeah. So that's a scale model. Let's talk about this car right here on page 513. It says it's a miniature replica of a 1923 checker cab. It says the length of the model is 6.5 inches. All right. So if you actually measured the car, the model car, it's six. I said 6.5, didn't I? So let's put it in there. 6.5 inches. So 6.5 inches. So that's the actual length of this little model car. Of course, that's not the actual length of the real full-scale 1923 car, is it? Of course not. I don't think they were that small back then. And the question says, Oh, the actual length of the car was 13 feet. So this is the model. I'll just do this. I'll put a word here. I'll put this is our model car, and this is our actual car. Okay, so our actual car was about 13 feet. And so what I want to find is I want to find the scale factor. I want to find the scale. What scale is this model right here? You could compare the small one to the large one or the large one to the small one, and it really doesn't make any difference. Let's compare. I think they usually go from the smaller one to the larger one. So what do? We make a ratio. It's 6.5, right, inches over what? 13 feet. And you'll always reduce if you can reduce. Well, 6.5 actually goes evenly into 13. Did you know that? That goes once, and this goes twice. So what's the scale factor? It's 1 inch to 2 feet. You could write it like this as well. You could put 1 inch and then a colon, right? You've seen that, to 2 feet. It means the same exact thing. So that means for every inch on this model, you're going to go 2 feet on the actual car if you wanted to replicate the car or something like that. Okay? Pretty simple, right? Now, the next question says, that was the easy part. The second question says, how many times as long as the actual car is the model? So does it mean the car is twice as big as the model? No, because look, this is 1 inch and 2 feet, right? So that means it's not twice as big, because if I go 1 inch on the model, that means I'd only go 2 inches on the actual car, right? If it was twice as big. But it's 2 feet. So how are we going to do that? Well, it's a good question. Watch what we're going to do this. Watch what we're going to do. See how I have inches on the top? I want to find an actual scale to this. I don't want the units now. I just want, for every one of these things, I go 2 of these. For every 1 inch, I go whatever, how many inches, or how many, for every foot that I go on this, I go how many feet on the real one. So what we're going to do is this. We see the 1 inch right here. I want to get rid of the inches, so I put inches on the bottom. I got feet on the bottom, so I want to get rid of feet, so what am I going to do? Put that on the top. Now you got to do your scale factor here. How many feet equals how many inches?
12 inches equals 1.
That's right. So the 12 goes with the inches, would you agree? And the 1 goes with the foot. Everybody understand that? All right, because the inches will cancel out and the feet will cancel out, and then I can see how many times bigger is the actual car compared to the smaller car. And what is that? It's 1 over what? 24. So it's 1 over 24 what? Is it 1 over 24 inches or centimeters or feet or yards or miles? No, it's anything. It's for every any unit that you go, you're going to go 24 of that unit. So if I went 1 inch, then what would I have to do on my car? I'd have to go 24 inches, okay? If I went 1 foot, then I have to go 24 feet, okay? Does that make sense? All right, now that's a long car, 24 feet, but look, the actual car is 13 feet, the model is 6.5. So if I actually go, what number did I say? I just forgot. What number did I just say? How many feet did I? You just said it. You just said 2 seconds ago.
I know, I'm just like feet.
I know, but you said a number. I can't believe I just forgot that. I said it like 5 seconds ago. Oh well, rewind it and we'll find it. I don't care right now. All right, so 1 over 24 is our scale to that thing. Pretty simple stuff. All right, and yeah, and that's basically it right there. I mean, I talked probably about 15 minutes too long, but that's okay. And that's the kind of stuff they're going to ask you to do. They're going to give you some maps, right? And you got to figure out, okay, if it's this many inches on the map, how many miles is it? Okay. Then they'll give you a model. They'll say, okay, here's your scale to this model. If it's, if your model is this many inches, how many feet or how many inches is the actual car or train or whatever you're talking about. So that's pretty much all there is to it. It's not that big of a deal. Usually the last lesson's really hard and tough, isn't it? But that wasn't that bad at all. All right. That's it. Let's do some problems. Yeah, you'll have plenty of chance to do some hard problems.
Do you have rulers we can?
Yeah, they're all. I don't know if you have to use rulers on
Yeah,
these.
you do.
Do you?
Yeah.
Do they say that? Okay. All right. That's fine. It's a good idea. Yeah, well, get a ruler. And
We can use so we can start. 15 minutes.
I don't know if I have one for everybody, but maybe. Yeah. I do have quite a few rulers. We'll see. Let's give you the problems that we're going to do first. It's pages 514 to 516, and it's a lot of pages because the pictures are kind of big and takes up a lot of space. I'm just doing 5 to 19. Okay, and that's section 7-7. There it is. And we have a quiz tomorrow. Let's write that down too. I'm going to tell you. Quiz on 7.3 and 7.4. 7.3 and 7.4. And that is tomorrow. Almost broke out in song there. Do you even know what song? Yes.
What?
Was it Annie? I said I almost did. I didn't. The was it Annie or something like that?
Annie.
Yeah, that's what it is. Okay, there you go. Like I said, this is probably about 18 minutes longer than I really needed to go, but you've got it. All right, quiz tomorrow. Be ready for it.